Good morning, students. Up to now, we have studied about work. Okay, any physical or mental activity called as a work, but work has a special meaning in a physics. Okay, we can say work is done when and when if applied force is capable to displace that object from one position to another position. If displacement in an object takes place, then and then we can say that work is done. Also, we have studied about the what happens if force and displacement are not in a one particular angle. Okay, means that is not exact in same direction. Force as well as displacement are not in same direction at that time. What happen? Okay, so if there is somewhat angle between force and displacement, then we see a formula of work done will become F into S cos theta. Okay, where this theta is the angle between force and displacement. On this angle, this cos theta decides how is our work. Okay, if you apply force in the direction of displacement, means both are in same direction, then our theta will be equal to 0, then our work will be equal to F into S. Okay, if the angle between force and displacement is 90 degree, okay, means direction of displacement and force are perpendicular to each other, at that time cos theta will be equal to 0 and our work done become 0. Okay, also we are studying one case if force of direction is another and force and direction of displacement is opposite to force. Okay, at that time this cos theta, that is the 180 degree, it will be equal to -1, so our work done is -1. Okay, so simply the theta matters work done, that we studied in last lecture. Also we studied the types of work done. Okay, positive, negative and zero work. Positive work means simply if direction of force and displacement are same. Okay, if you apply force on an object, then it displaces an object in that direction, then we can say that work is positive. Then also we studied negative work. Okay, when work is positive, when theta is equal to 0 degree. Okay, means force and displacement direction are same, at that time that work is called as the positive work. Then negative work, that is when direction of force and direction of displacement are opposite to each other, at that time such a work is called as a negative work. So such a cases happen when this theta is equal to 180 degree. Okay, because cos 180 is a -1, then our work done will become to -F into S. Okay, and last is zero work. Zero work is what? Simply when direction of force and direction of displacement are perpendicular to each other. Okay, means angle between force of direction of force and direction of displacement is 90 degree. At that time our work done is 0, because cos 90 is 0. Simply this theta is important in case of calculation of work done. So we have to remember cos 0 is equal to 1, cos 90 is equal to 0 and cos 180 is equal to -1. Okay, so that much part we have to remember. It is important because it may be asked in examinations. So today now next topic we have to start, that is unit of work. Okay, so we have studied the formula of work done. Work done is given by force into displacement. Okay, so force has a unit Newton and this displacement has a SI unit meter. So we can say that Newton meter is a unit of work. Okay, Newton meter. This Newton meter is also called as a joule. Newton meter is called as a joule. So we can say that we have to calculate 1 joule work done. Then we can say that 1 joule will be equal to 1 Newton into 1 meter. Okay, 1 joule is equal to 1 Newton into 1 meter. So from that we can define 1 joule in work done. Okay, 1 joule work done is what? Simply if we apply 1 Newton force on an object, then due to that force, if 1 meter is the displacement produced in an object, then that work done is called as a 1 joule work. When if we apply 1 Newton force on an object, due to that 1 Newton, if that object displaces through 1 meter distance, okay, then that work done is called as a 1 joule work. Okay, joule is a unit of work, that is a Newton meter is also called as a joule. Okay, so from this formula we can easily understand the formula of work done. Force is Newton and displacement is meter, so Newton meter is called as a joule. So here 1 joule will be equal to 1 Newton into 1 meter. Then CGS unit of this work done is erg. Okay, this is the SI unit. This is SI unit. Joule is SI unit and erg is CGS unit. So we can say that 1 erg will be equal to force. Here in SI system it is given in Newton. Now in CGS system force is given in dyne. Okay, and into displacement. Displacement in SI system given in meter. Similarly, in CGS system, displacement given in centimeter. Okay, so we can say that 1 erg is equal to 1 dyne into 1 centimeter. But we know, here we have to see now the relation between joule and erg. Okay, both are the unit of work done. One is NKS, that is the SI unit, and second is CGS unit. So what is the relation between joule and erg, that we have to see now. Okay, but we know 1 Newton is equal to 10 raised to 5 dyne. Okay, 1 Newton is equal to 10 raised to 5 dyne. Both are the unit of force. One is SI system and second is CGS system. So 1 Newton is equal to 10 raised to 5 dyne. Similarly, 1 meter is equal to 10 raised to 2 centimeters. Okay, what? 1 meter is equal to 10 raised to 2 centimeters. Then we know formula of work done is force into displacement. Okay, so here 1 joule will be equal to 1 Newton into 1 meter. Okay, 1 joule work done means what? Force into displacement. If a 1 meter force capable to displace an object through 1 meter, then that work done is simply called as a 1 joule work. So 1 joule is equal to 1 Newton into 1 meter. So here 1 joule is equal to 1 Newton is how much? 10 raised to 5 dyne, and 1 meter is 10 raised to 2 centimeter. So here it will be 10 raised to 5 into 10 raised to 2 will be 10 raised to 7, because if it is in multiplication, according to rule of indices, power will get added. Okay, so here 10 raised to 7 erg. So this dyne centimeter is also called as a erg, and Newton meter is also called as a joule. Okay, Newton meter is called joule, and dyne centimeter is also called as a erg. You have to remember that. Okay, so here 1 joule will be equal to 10 raised to 7 erg. So we can say that 1 joule is equal to 10 raised to 7 erg. That is the relation between joule and erg. Okay, 1 joule is equal to 10 raised to 7 erg. Okay, simply sometimes this relation is also asked in examination. Prove 1 joule is equal to 10 raised to 7 erg. Okay, so for that you have to remember only this formula of work done. From the formula we have to go toward this proof. Okay, first of all we have to calculate 1 joule work done. For that we should know the definition of 1 joule work. 1 joule work is simply what? If we apply 1 Newton force an object, then due to that 1 Newton force, if displacement produced in an object is 1 meter, then that work done is called as a 1 joule work. Okay, and its SI unit is Newton meter, that is the joule. Okay, in CGS unit, that is the erg, 1 erg is equal to 1 dyne into 1 centimeter. This relation also you have to remember. From that 1 Newton is equal to 10 raised to 5 dyne, and 1 meter is equal to 10 raised to 2 centimeter. Just these two values we have to use in this formula, because force 1 Newton is equal to how much? 10 raised to 5 times, and 1 centimeter is equal to 10 raised to 2 centimeter. That is the 1 joule work. Okay. So according to rule of indices, both are in multiplication. So 5 plus 2 will become 7. So 10 raised to 7 or 1 joule is equal to 10 raised to 7 or. Okay. So this part also important that you have to remember. Okay. Okay. So next topic we have to see, that is energy. Okay. So energy is very basic thing that we have to use to do every work. Okay. Unless of energy we can't do any work. Okay. Energy is must necessary for doing any work. Okay. So we know we are using different types of energy. Okay. We use electric energy. Okay. Also we use mechanical energy. We use kinetic energy of an object. We use potential energy of an object. We use chemical energy of an object. Also we use nuclear energy. We use solar energy. Okay. So these are the different types of energies. Okay. That energy must require for doing any work. Okay. Unless of energy we can't do any work. Okay. So simply first we have to see what is the definition of energy. Okay. Definition of energy is the capacity of a body to perform work is simply called as a energy. I already told you, unless energy no work is possible. Okay. So simply we can say that energy is a very basic thing required to perform any work. Okay. Capacity of a body to perform work is simply called as a energy. Okay. Without energy nothing is possible. Simply our mobile phones also require energy. Okay. If it is get discharged, then it will be switch off, because all energy is consumed by all the functions. So we have to charge it, we have to give energy. Okay. So similar way to doing any work we also need energy, and that energy is not simply the capacity of a body to perform work, it is simply called as a energy. Okay. So now in this year, so there are different types of energy. I already told you, potential, kinetic, that is the mechanical energy, also solar energy, nuclear energy, electrochemical energy. Okay. So these are the different types of energy. Among that we have to study only about mechanical energy. So mechanical energy is nothing but the combination of potential energy and kinetic energy. Combination of potential and kinetic energy is simply called as a mechanical energy. So we have to study only these two types of energy, kinetic energy and potential energy, in this chapter. Okay. So only we have to think about it. Other part we will see in some next standards. Okay. So suppose first of all we have think about the kinetic energy. Okay. Simply kinetic means what? Kinetic means, meaning of this word kinetic is motion. Okay. Kinetic energy, kinematics is the branch of physics. We deal with the study of motion. Okay. And kinetic, the meaning of word is motion. So whatever the energy gained by any object due to its motion, kinetic means what? Motion. Energy gained by an object due to its motion is simply called as a kinetic energy. Okay. Now suppose one object is moving very fastly and one object is stationary. If that fast moving object is strike on stationary object, at that time what happen? We know if object is moving, it means it has a somewhat energy due to its velocity. Okay. And that energy is simply called as a kinetic energy. Means that moving object has a kinetic energy, and one object is stationary that you consider, it is stationary, means it don't have any kinetic energy because its velocity is 0. So when that fast moving object strike on an object, okay, due to that what happen? When that will be strike on an object, at that time the stationary object will be moved. Okay. So we know if we want to move any object, then we must require or we must have to do some work on that object. Then and there what happen, the stationary object we can move. Okay, so here what happen, we know that speedily moving object has a kinetic energy. Due to the collision between two objects, what happen, it gives it some kinetic energy to stationary object. Okay, some kinetic energy or kinetic energy. Okay, if that fast moving object stop after collision, then we can say that all the energy it transfer to that stationary object. Okay, so such a way that we can say that if you want to move any stationary object from its original position, then we have to do some work there. But what happens, as this moving object strike on that object, due to that strike what happens, that stationary object move. Okay, so due to that kinetic energy, that object move means this kinetic energy we have to use here for the work done. Okay, that all kinetic energy get used to the work done on that stationary object. So we can say that kinetic energy gained by an object. Okay, initially one object is stationary and one is moving. After collision, that stationary object start moving. It means that some work done should be happen there, and that is due to the kinetic energy of that second object. So we can say that kinetic energy gained by an stationary object is nothing but the work done on that object due to that kinetic energy. So we can say that kinetic energy is equal to work done, that is the F and F into S. Okay, so what happened here, kinetic energy is nothing but the what, work done on an object. That thing we have to remember, because this we have to use in further some part. Okay, whatever the next topic we have to see, in that we have to use this logic. Whatever the kinetic energy gained by a stationary object, that is nothing but the work done on that object. Okay, now that we have to see one problem. Okay, here problem is calculate the work done to take an object of mass 20 kg to height of 10 meter. Okay, if one object is on ground, we have to lift that object 10 meters above from the earth surface. Then how much work we have to do for that we have to calculate here. Okay, so first of all we have to write given data. Okay, given data is what, mass is given, which is the 20 kilogram. Then displacement is how much we have to do, that is the 10 meters. Also acceleration due to gravity on the earth surface is 9.8 meter per second square. Okay, that much data we know, and that we write here. Okay, then first of all we know formula of work done is force into displacement. Okay, but now here force is not given. Okay, simply force on an object is whatever the gravitational force act on an object is nothing but its weight. Okay, so its weight, and that weight is nothing but the force. Okay, that weight is simply what, force. So here we have to calculate that force. Force is given by m into a, but on the surface of earth acceleration due to gravity is how much, g, and it is equal to 9.8 meter per second square. So instead of this a we write here g. Okay, so F will be equal to m20 and z minus 9.8 meter per second square. So F will be equal to minus 196 Newton. Okay, so here sign is negative. Okay, why? Because we know earth always attracts object towards its center, but we move that object opposite to that motion. Okay, always simultaneously try to pull that object towards center of earth. So that is why whatever the work force we are applying here, that is opposite to the acceleration due to gravity, earth's gravitational force. That is why this sign is negative. That also we have to remember. Then we know, now we have F. Also we have S. So now we can calculate work done. Okay. So work done is equal to force into displacement. So force is minus 196 Newton into displacement is 10 meter. So it will be equal to 1960 Joule, and its sign is negative. Okay. Actually work done is not negative. Okay. If you calculate any time, work is never negative, but here whatever the work we do, that is opposite to the gravitational force. That is why this sign we have to given here negative. Its sign of negative meaning is we are doing this work done against the gravitational force. Okay, that you have to remember. That is why we have to give here sign negative. Okay, so such a way that we have to solve problems based on this chapter. Okay, so in next lecture we will see about kinetic energy and its expression. Okay, thank you.